Hello, my 12th standard warriors. Time to study the eye, the microscope, how it works, what's the magnification, and what's the difference in construction of a microscope with a telescope, and what's the working behind a telescope. All of this in today's session of optical instruments and obviously the eye and how to correct its defects in today's session with me, your captain, your navigator on this channel. Hello Vicky, Gokulnath, nice to see you in the live. Hello Kopu, hi Kavya, Tamil, welcome Aisha, Arvind, welcome all my lovely warriors. So what are we going to exactly see in today's session? I'm going to give you the flow of the class. So we're going to start with the eye, how the least distance of distance work, and then we are going to go to simple microscope or magnifying glass, and then we are going to go to compound microscope and then the telescope, and also see the resolving power of each of these devices. Lots of problems planned in today's session, so stay tuned with me, your master teacher on this channel. My name is Shreyas, teaching kids for more than 10 years, and having this experience makes me feel very proud because many of my students have not just aced JEE with amazing 2-digit ranks, but also many of them, they are in the top-notch colleges no matter where they are, and I'm pretty sure this year you too want to crack the JEE examination and want to excel and come out with flying colors. So stay tuned. And how many questions from this chapter? There could be one question at least from this chapter, so 4 marks in your pocket in today's session. Thank you EGL for the colorful hearts. Hi Jiva, hello Nikhil, Sandeep, nice to see you all. I hope you guys are doing well, and I hope you guys are all excited for today's session, because there are times when questions are asked from this chapter in JEE Mains and 4 marks are guaranteed from this chapter. Again, this is an easy chapter. You just have you can say that initial hesitation, because sometimes the theory might look very confusing, but trust me, in today's session all of those doubts will be cleared. So let's start with an easy question. Thank you Rizwan for all the love, bacha. And yes Jiva, it will also help you in NEET as well as boards. Hello Rudra, hello Blessing, nice to see you back. Hi Sajid, hello Sandeep, hello Dazid. Welcome aboard all my lovely warriors. Yes, it's going to help JEE, NEET and CBSE board and all the other state board students as well. Don't worry. Here it is. If you had a person who had only one eye, then what do you think will happen? The image of the object would have been inverted. The visible region would have decreased. Image would have not been seen in 3 dimensions. He will be a pirate. More than one option is possible in this question. JEE Advanced type. Let's see how many of you can solve this. Yes, Vicky, it will obviously help in all the CETs as well. Varalakshmi saying B. Hi KBR videos. Hi Shreyas. Blessy saying C. Interesting. Some of you are saying B, some of you are saying C. I'm telling you, more than one option may be correct. So multiple options could be correct in this question. So think carefully. Somebody is saying B and D. Well, the correct answer is, the D option was just there for time pass. It's just to play around with you. Obviously, why will he be a pirate? It's not necessary that a pirate should have only one eye and it should be covered with, a black cloth or something like that. No, it is not D. It is just there for fooling you around. That's it. Image of the object will be inverted. Come on guys, just close one of your eye. Does the image get inverted? Obviously not. Everything is still upright, so image will not be inverted. But the moment you close one eye, you will be able to see less. Some of the parts are not seen, some of the objects are not seen around you. So the visibility will reduce. Of course, the image would not have been seen in 3D. What happens is, when you have two eyes, you can perceive depth very easily and you can see objects in 3D. But the moment you have only one eye, you will lose that sense of 3-dimensionness. The depth feeling goes off. That's the reason why it is B and C. Alright my warriors, fair enough. And yes, I hope you have not forgotten to hit the like button for today's video. Some of you already do that even before the video starts. It shows your immense love and support, and thank you so much. And that's your Guru Dakshina for watching this video on this Enthuse channel, the dedicated English medium channel for JEE, for KVPY, for BITSAT and all the other board examination preparation, and one of its kind in this country. Okay, so well, don't worry, Rahul, Madesh, you can leave a comment after the video ends. I'll definitely help you with your revision plan. You can just leave a comment so that I can respond to you in detail rather than, spoiling the flow of the chapter right now. Don't worry, I'll help you out. So also remember, those of you who have not yet joined Vedantu, I'll give you one simple reason why you should, take support of Vedantu, even if you have enrolled in some coaching or even some online class, maybe anywhere. The reason is, it's because of the best teachers, it's because of the amazing content, and to prove that fact, it's right over here, more than 1,500 students last year cleared JEE Advanced. That means almost 6% of the students entering IITs were from Vedantu alone. Thousands more have cleared JEE Mains with amazing percentiles above 95, above 99, above 90, so many thousands of students. So that means that proves our methodologies work, and this year there are more sets of new questions coming up and more assignments and amazing test series planned for you. So make sure you don't have to travel anywhere. At your fingertips, you can make use of the crash course for droppers as well as for the fresh 12th standard students. So on offer, on discount, you get the crash course at 50% off up to 2,000 rupees. Usual price 20,000, offer price 10,000. With discount, you will get this for 8,000 rupees, 90 sessions. So that's amazing deal. Go ahead, check it out because this is a Republic Day offer. And yes, the crash course is in English. So check it out. Let's get going. All right. Now, yes, please keep taking notes, Nikhil. All right. So BITSAT, it's too late. Or rather, I would say it's too early to announce now, and it will be very late. Don't worry about it. Okay. Now let's talk about the human eye. See, human eye is a miraculous lens. Reason why I'm saying it is a miraculous lens, because a normal lens has a fixed focal length and a fixed aperture. Aperture means the size of the lens. But the eye has so many muscles, so many things to pull and push around that it can contract, it can expand, it can change its aperture size, all of that, and it can change its focal length. Because you can try this out even now. Hold an object and see, you can observe that object very clearly. You move the object around, you will see, you can still see it clearly because the eyes adjust itself. Choose the focal point. Just like in your camera, in your mobile phone camera, you can choose the focal point, right? Haven't you tried this? So basically what happens is, eye has an adjustable focal length and it changes the focal length as per where it is focusing, so that the image is always formed on the retina. Retina is like the screen of your eye where the image is formed. Only when the image is formed on the retina, then the brain, the optic nerve sends signals and the brain perceives the image clearly. If the image is not formed on the retina, if it is before or after, it is blurred. So sometimes when you see blurred or when you are not wearing your spectacles, the images are not formed on the retina. Alright, the muscles which stretch, pull, the eye lens, they are also called as the ciliary muscles. They basically adjust the focal length of your eyes. Is that clear, my warriors? Understood? So look at this beautifully, the way eyes, look at the image. And by the way, I don't know whether you know this, the image formed on the eye is real. Image formed on the eye's retina is real, and hence it is also inverted in nature. Inverted in nature. Very, very important. You'll be like, sir, it is inverted. That means whatever I'm seeing is not like this, it is ulta. No, it is not upside down. It is as it is. The brain knows it, that the eye has by default inverted the image. So the brain inverts the image. So beautiful. And sends it to you. So you see everything around you as it is. If brain did not have that processing power, then it would look very weird. I hope this is clear. Shreyas, laws of motion 11th chapter upload ಮಾಡಿದಿ ತುಂಬಾ ಸಮಯ ಆಗೋಯ್ತೆ. It's done long time back. Okay, you can find it out in the nurture series. Shreyas. All right. Yes, intelligent brain. Rahul, Mahesh, Deepak. Hello. Calm down. Okay. So moving ahead, the accommodation of the eye is also very important. Eyes can accommodate, like I said, by adjusting its focal length. So when you place an object close enough, the eye gets strained. The eye is strained because the muscles are under strain, the ciliary muscles, and it tries to reduce the focal length because when the object is close, it has to converge the rays on the retina. So it has to reduce its focal length, it has to increase its power. Agreed? Now, what happens is, there are times when the eye's muscles or the lens is unable to contract, it's unable to push it, so that it can reduce its focal length and form the image. Okay, and there is a distance till which it can actually focus. So the distance till which you can bring the object and the muscles can contract, so that the focal length is small enough so that the image is formed on the retina of your eye. That distance is called as the least distance of distinct vision. What is it called? It is called as the least distance of distinct vision. That means beyond that point, the eyes will be unable to stretch or act upon to reduce the focal length. That's it. After that, you will not see the image clearly. So that is called as the least distance of distinct vision. For small babies, when you're a kid, that distance is around 7 to 10 centimeters. That's very small. You can see things which are very, very close by. But for an average person in an adult, you will see that the distance is around 25 centimeters. As you grow older, this distance can even increase to maybe even 1 meter or 2 meters. That means anything till 1 meter or beyond 1 meter is fine, but from 1 meter to your eye, you will not be able to see clearly. That's when you have some defect, and that's when you age. I hope this is clear. Yes, as you age, it degrades. It degrades as in it does not become less, it becomes more. More is bad, less is good. Understand that. Okay. Now, the other thing which happens with the eye is when you take the object far away, then the eyes become relaxed. That's why they say when you're watching something continuously, make sure that you close your eyes, do some eye exercise, look at something far away. Because when you are looking at something far away, your eyes are relaxed, and you do not want your eyes to be strained when you are glued to your mobile phone or glued to your laptop screen. So every now and then you should look around after every 20 minutes or so or 10 minutes or so. Look around, look at some far away object, relax your eyes, and then again look at your screen. Is that what you do? Is that what you do, guys? Well, if you're not doing it, please do that. You need to relax your eyes. Gently massage your eyes, close and open your eyes so that your eyes can also take rest, just like you sleep in the night and take rest. Now, the problem is some eyes cannot relax too fully. There are some students, no matter what, even when there is a party going on, even when there is some birthday or some celebration going on, they are under tension. Oh my God, so many chapters to complete. Oh my God, this homework. So these are tension party. These people are tension parties, right? So there are some eyes, there are some people who have some defect where the eyes cannot relax fully. Even if you want to see a distant mountain, the eyes cannot relax. So that means you will be unable to focus on objects beyond a certain distance. That is also a problem. But for an ideal eye, it is infinity. For a good eye, healthy eye, it is infinity. That is also called as the far point. Yes, Nikhil, I made a session with Dr. Vineet Joshi, who was from LV Prasad Institute, Hyderabad. Yep, he told you how you should exercise your eyes. And if you have not seen it, please watch it. It's there on our channel itself. So that is called as the far point. The far point is basically till that point, that farthest point till which you can see clearly. Usually what is the far point? It is infinity for a healthy eye. For an unhealthy eye, it will be maybe, I don't know, maybe 10 meters. maybe even 5 meters, maybe 7 meters. That means after 7 or 10 meters, he will not be able to see. He will not be able to see anything beyond a certain point. That's bad. So you will not be able to see traffic lights, or maybe you will not be able to see what the teacher is teaching on a board and all of that. That is also bad. All right. Hi Nivida, welcome aboard. Yes, Abhishek. Let's have a look at some questions, but before that, let me tell you, if you want the theory slides, if you want whatever I write over here, all these notes, it's available in our channel Telegram group. Remember, this is the new channel. You might have joined the old channel. Please join the new channel. That's the JEE Enthuse English, and all the updates happen over there. All the updates, all the notifications, all the PDFs, everything, solutions, everything, you will get it over there. Okay? Having said that, let's move ahead to some questions. A defective eye cannot see close objects clearly because their image is formed. Come on, let's see how many of you can get it. Let's see how many of you can get this. If there is a person with a defective eye and he cannot see the objects which are close enough clearly, why is that happening? What is the problem? The image formed is on the eye lens, between the lens and the retina, on the retina, beyond the retina. Guys, some options are obviously eliminated. On the eye lens, come on, how can it form on the lens? Number 2, if it is on the retina, then how is it a defective eye? If it's a defective eye, then the image is not formed on the retina, right? So C and A option are automatically eliminated. Obviously, do you guys get it? Okay, so then where is it formed? Okay, many of you are saying B. Some of you are also confused between B and D. See guys, the actual answer is D. It is beyond the retina. Remember, when you are bringing it close enough, then the eyes are strained. The focal length has to reduce. The rays have to converge quickly on the retina because you are bringing the object close. So the power of the lens should increase. But that person has a defective eye. That means he is unable to focus. So the rays are unable to converge. If they are unable to converge, the rays will meet behind the retina. Look at this. Very, very important, the diagram. Not the above one, the below one. Look at this. The rays are meeting behind the retina. The rays are meeting behind the retina. This can happen because of two things. Either because the lens of the eye is weak, you are unable to focus. Number 2, the eyeball is elongated. Okay, the eyeball is elongated for some reason. So these are the only two ways. But anyways, so you get the idea. The eye's lens are unable to focus it, so the image is formed behind the retina. That is also called as hyperopia. But the other defect, where the image is formed in front of the retina, between the lens, that is called as myopia, the other defect. Yep. It tries to go to infinity, not necessarily infinity, Rahul. It will just go behind. So usually what should happen, if you place the object here, the lens should be so powerful that the rays merge over here. But it is unable to do that because the lens has lost its power. So because of which it goes here. So to correct this defect, which kind of lens will you use? Come on, put it up in this. Selva, it is there in JEE Mains. It might be deleted in your respective boards or something, but it is not deleted from JEE Mains. So please study it. What kind of lens will you use to correct this defect? Isn't it obvious? Isn't it obvious? Concave? Nah, Rahul, think. If it's concave, the rays will diverge. The rays will diverge. Think about it for this defect. Hyperopia. Which lens will you use? You will use a converging lens, so the rays are getting converged over here. Hi, good evening, Popia. Welcome. Yes, I hope this is fun. Fine. Noshin. Oh, your name is Noshin. Hello. Yes, convex. Yes, some of you said concave. Concave is for myopia. Be careful. Myopia, concave. Hyperopia, convex. Hyperopia is when the rays are farther behind the retina, so you make them converge with a convex lens. That's it. Okay, fair enough. Let's see if you can solve this question. There is a person, he can see the objects up to a distance of 1 meter from his eyes, up to 1 meter. For correcting his eyesight so that he can see the object at infinity, he requires a lens whose power is. Let's try and understand what this question means. Okay, see, this is our human eye. All right, this is our human eye. Okay, and he needs a lens to correct it. I don't know what kind of lens it is, so I'm just going to put it as some blank thing. I don't know what it is. He's just going to wear it. This is a big question mark, concave, convex. I'm just leaving it as it is, and he can see till 1 meter. So he can see till here, and let's say this is nothing but 1 meter, which is 100 centimeters. Fair enough, which is also 1 meter. But he has to see objects beyond 1 meter also. You have to correct that defect. So this is the defective eye's far point. The actual far point should be infinity. So if you place an object at infinity, then the image, if it is formed here, if the image of that object, imagine you are seeing a distant mountain, very, very far. If it comes closer within his range of 1 meter, then he will be able to see the mountain. Do you understand this, my warriors? Do you understand this? If the object is very far away, if you make that image closer for him because of some lens, then he will be able to see that object. Actually, he will be seeing this. He will not be seeing this. He will be seeing the image of that. So that's it. Solve the question using your lens formula. So use your lens formula and solve it. You will get the answer. So 1 by V. V is nothing but this 100 centimeters, which is nothing but, what is it? Hold on. Yeah. V is nothing but minus 1 meter minus 1 by U. U is infinity. So just put infinity is equal to 1 by F. So therefore 1 by F is equal to minus 1 per meter. And remember, power is just 1 by F. So it is nothing but minus 1 per meter. Per meter is nothing but diopter. So it is minus 1 diopter. So that's the power of the lens that you will be using. Got it? Very good, Abhishek. F is negative. Yes, correct. So what kind of lens is this? This is basically that unknown lens. What is that unknown lens going to be? This unknown lens, since it is negative power, that means it should be a concave lens. It should be a concave lens. Hi, Sri Krishna. Jai Govind, like I said, you have to go on a date, right? On Valentine's Day. So we have to finish the portions by 14th Feb, before Valentine's Day. All right. So we are almost done. The only topic left is modern physics. Next week, entirely modern physics, and that's it, semiconductors, and then we'll be done. Okay, cool. Raghav, I will reply to you. Just hold on. Okay, I'll reply to you. I have replied to quite a few students on Instagram. Maybe your message would have gone to the others folder. I'll definitely reply to you. Okay, so this is what it is. It is basically myopia. The rays are converging before the retina. So you use a concave lens, and that's what you do. You use a concave lens and make sure the rays converge on the retina. That's what has been done. Hello Kavya S. Welcome. I hope you're enjoying the class today. Hello MS Prasad. Hi D Pratibha. Nice to see you all. Okay, welcome all the lovely warriors. Hi Nalala. I hope you have hit the like and the subscribe button, because that's very important so that you do not miss the further classes. Yes, Raghav, definitely. I will reply tonight only. Okay, I'll keep in mind. Okay, simple microscope. Let's study the three major devices: simple, compound, and telescope. Are you guys ready with me? All right. So simple microscope, this is the easiest of the all, and it lays your foundation for the other two. If you understand this, the other two become very, very easy. Trust me on that. So simple microscope is nothing but a magnifying glass or just a convex lens, which you would have always used for seeing something. I'm pretty sure you would have played around with magnifying glass at some point of time in your life. Is there anybody who has not seen a magnifying glass or has never used it? Okay, well, so basically, yes, I think everybody would have used. Now, what is the working behind it? It's very easy. Remember that, I have told you about convex lenses, and convex lens usually makes real images. Usually. And you do not see a real image unless you have a screen. The only time a convex lens makes a virtual image is when you place the object between the focal point and the lens. Correct? Remember that? You have drawn the ray diagrams. I'm pretty sure I have shown this to you on this channel in the past few sessions. So when you place it between the focal point and the lens, that's when the virtual erect magnified image is formed. So that's the whole concept of it. But before going to that, let's understand something called as the magnifying power. I'm guaranteeing you, many of you will not know what magnifying power is. Immediately many of you will say, sir, I think I know it. It's 1 by f. Nah, this is not what magnifying power is. So listen in carefully. Listen in carefully. Now imagine you're holding an object. Imagine you're holding an object. The object subtends some angle. Okay, I'll probably choose a colorful object. Maybe the black background does not make you realize what it is. If you have an object, the object subtends some angle on your eye, correct? It's some angle. As you bring the object closer, the object subtends larger angle. It subtends larger angle. Now, always remember one thing. Whenever you see something, some object, somebody, anything, if you want to see it clearly, you want it to be big. Now, when I say big, it does not mean actual size should be big. It means the angle subtended should be big. Because even a mountain is big, even Jupiter is big, even the sun is big, the moon is big, but they are far away. So the angle subtended is less. So what matters while seeing something clearly is the angle subtended should be large. Everybody understanding this? Everybody understanding this concept? Now, why do you need a microscope or a telescope? The reason why you need a microscope or a telescope is because the angle subtended by most of the things around you are small. Let's say you want to see coronavirus. Let's say you want to see some bacteria. Let's say you want to see the Jupiter. Let's say you want to see the moon. All these microorganisms or these planets are going to subtend very small angles. Do you guys agree with this? Yep. So you want to increase the apparent angle which is subtended on your eye. That's the whole purpose of some device like microscope or telescope. That's all. Now, it so happens that we define this magnifying power. I'll just show this to you first. The definition, and then I will explain this to you, the statement. It is the ratio of basically, or the factor by which the image on the retina is enlarged by using an aided instrument. Well, you might not get it so easily, so don't worry, I'll help you with this. Now, without any aid, without any microscope or telescope, let's say I place an object. So this is my object, all right, and this is the human eye over here, and this is how it is. Fair enough. Now, let's say this is the angle over here, like you can see. Let's say I'm going to call it phi. This is the angle subtended by the object. Let's say it is of height h, and let's say you bring the object close. What is the maximum distance you can bring it till you can see it clearly? The maximum distance that you can bring it close enough is basically your least distance of distinct vision, right? So that's the maximum possibility of bringing it closer. Beyond that, you will not be able to see it clearly enough. So this is D. This is the best angle you can get for an unaided eye. For an unaided eye. Everybody agrees with this? For an unaided eye, this is the best possible angle. This phi is the angle subtended by the object when you place it without any instrument as close as possible. Alright. Now this phi will be approximately equal to, for small objects, if the object is small, then tan phi will be small. So phi will be equal to tan phi. So therefore, it will be nothing but h by d. Opposite by adjacent. Everybody agrees? Everybody agrees with this statement? Perfecto? Great. Now, let's say you add some aid. You use some instrument. I don't know, it could be any instrument, because of which this is the image formed. This is the image formed. I don't know. Now the image could be formed at some other distance. So this is your eye, and maybe this is some kind of an instrument. This is the aid. Okay, this is the aid which you are using. Now it will subtend some other angle. It will subtend some other angle. Let's say I call it theta. Now the value of this theta, which is approximately tan theta, will be now the image height. I don't know, I can just call it as hi, and let's say this is that distance. I can call it xi, whatever you want to call it. So it will be nothing but hi by xi. Okay, you can just give it any numbers or variables that you want to. So basically theta is for the aided eye, phi is for the unaided eye. This magnifying power, okay, this magnifying power is nothing but the phi value divided by theta value. This is what the magnifying power is. So basically, oops, sorry, I made it ulta. I'm so sorry. Now, right, this magnifying power will be theta divided by phi. Theta divided by phi. Theta is for the aided eye, so that means it will be more. Phi is for the unaided eye. So this is for basically aided eye, and this is for the unaided eye. So this number generally should be more than 1, as simple as that. Ramya, there is no JEE Advanced questions on EM waves because EM waves was never asked in JEE Advanced. Okay, because it is not in the syllabus only for JEE Advanced. Is that understood, my warriors? So what is magnifying power? It's the ratio of the angles, not the ratio of the heights. That's what you should understand. So that means aided eye means with some instrument, some device, magnifying glass, microscope, something. It could be anything. So it's with the help of the device what angle it is subtending. Is that okay, Kopu? Everybody give me a thumbs up if you guys have got it till here. Magnifying power is aided upon unaided angle, subtended. Got it? Fair enough. Let's move on now. Let's talk about simple microscope. Observe this carefully. Okay, so first of all, we know that, very good Naveen, very good, keep it up. Okay, so we know that for a simple microscope, we should place the object very close to the lens. In fact, before the focus, very close to the lens. So this is our object, let's say. Okay, and the rays from the object are going to travel somewhat like this. Okay, they are just going to travel like this, and they are going to go through the focus. So let's say this is the focal point, so they are going to go through the focus. I can draw another ray which passes through the center of the lens, that will get undeviated. And if I extend it somewhere over here backwards, if I extend these rays somewhere over here backwards, I'm just drawing it randomly, guys. Ignore the actual geometry over here. Okay, so I know that the image will be formed somewhere over here. This is where the image will be formed. This image is obviously virtual, this is erect, and this is also magnified. You can see that very easily. Always while doing these kind of questions, it is understood that, or rather it is assumed that the eye is placed over here, very close to the magnifying glass. So all the distances when measured from the lens are also indirectly measured from the eye. You're holding the lens very close to your eye. Remember that. That is the assumption every time for every device. When you are seeing through a microscope, you're seeing or keeping the eyepiece very close to your eye. Or even a telescope, you're holding the telescope very close to your eye. That's the inherent assumption. Fair enough. Now, let's talk about the magnifying power. Before that, let me mark the distances as well. Observe that this will be your image distance. This will be your image distance. And over here, this will be your object distance. I hope you can see that. Okay, this will be your image distance and this will be your object distance. Everybody clear about this? Very good. Now, let's try to think about this. There are two ways you can place the object, and this is very important. Two ways. One, the object is placed such that the image is formed very far. That means your eye is relaxed. The image is formed very far, your eye is relaxed. You're seeing through the magnifying glass in a relaxed manner. Second time, you're placing the object in such a way, the image is formed as close as possible. That means at the least distance of distinct vision. That means your eyes are heavily strained. So two possibilities are there. So let's try to do this. Okay. So what we need to do is take those two cases. The first case, basically, normal vision. So when I'm saying normal vision, basically the eyes are nothing but relaxed. If the eyes are relaxed, think what will be this value of V be equal to? The value of V will be as good as infinity, because the image is formed at a very large distance. Your eyes are least strained. Agreed to this? The second thing, if the image is formed at infinity, where is the object kept? The object is kept at the focal length. Everybody agrees to this part as well? Now think about this. If I tell you what is the magnifying power? Well, magnifying power, if you remember, it was theta by phi or phi by theta, where on the numerator you had angle subtended with the aid, and in the denominator you had the angle subtended without the aid. Correct? Without the aid. So without the aid, that angle which was subtended was nothing but the height of the object upon d. If you remember this clearly, it was height of the object upon d, and here you had that theta. This is with the aid. Now think, what is the value of theta with the aid? That means with the magnifying glass. Observe carefully. This image, which is at infinity, will subtend this angle. I don't know whether you can see it, but it's right over here. This will subtend this angle, okay, at the eye. Can you see that? This is the angle subtended by the image at the eye, which is almost the lens. And this yellow line over here is nothing but the height. It's nothing but the height of the object, and the object is placed at a distance of u. So think carefully, what should be the value of theta? Because I need the value of theta. I think I can get it. Can you guys tell me in the chat box? Can you guys tell me in the chat box what should be the value of theta? Because theta is the angle subtended by the image with the aid, that means with the help of the convex lens. So think carefully, what is the value of theta, my warriors? Shouldn't the value of theta be tan theta, which is opposite by base? Opposite is h and base is nothing but u. So this divided by h by d. But h goes, and u, what is u? U is nothing but f. So it will be 1 by f divided by 1 by d. That means it will be nothing but d by f. So this is your magnifying power for the normal or relaxed eye. Relaxed eye. Everybody gets this? Excellent. H by u, right? Put the value of u as f. H cancels, so it will become d by f. Perfecto. This is for normal eye. Now the second case. Let's have a look at the second case. So what is my second case, my warriors? Observe this carefully now. Okay. Yeah. Second case is when my eyes are most strained. Most strained. That means for least distance of distinct vision. So when my eyes are most strained, where should the image be formed? The image will be formed at D. D is 25 centimeters, but let's leave it as an unknown because from person to person it can vary. Fair enough. Now if V is equal to D, I want to find out what is the new magnifying power. If you notice, magnifying power over here is, after HH cancels, it is D by U. So probably I need the value of U. Understanding it? I need the value of U. How do I find the value of U? I can find the value of U by lens formula. So let's use lens formula and see what happens. So 1 by V minus 1 by U is equal to 1 by F. So 1 by V. V is nothing but D, but D is negative because you're on this side. Even the object distance is negative. I hope you can see that because you're on the negative side. And this will be equal to 1 by F. I hope you can see that. So from this, I'm going to get 1 by U is equal to 1 by D plus 1 by F. I hope you can see that, my warriors. Let's play around this with this a little bit more. So I'm just going to get 1 by U is equal to D plus F upon DF. Interesting. Last thing, probably I will need the value of D by U somewhere around, because D will go on the top, U will come below. That's my thinking. So let's just find the value of D by U. What will be the value of D by U? It will be nothing but D plus F divided by F. Now, why did I find the value of D by U? You will understand it now. The magnifying power, which is theta divided by H by D, will be where theta is H by U. Theta is H by U divided by H by D. You can solve this, H cancels, you will get this as D by U. That's the reason why I found this D by U. Same logic what I have used over here. And what's the value of D by U? It is D plus F by F. So it is D plus F divided by F. So this magnifying power, you can see what it will become, 1 plus D by F. So the point over here is the magnifying power is slightly more by 1. It's slightly more by 1. So that is what is important. So when your eyes are relaxed, yes, you can relax, but then the magnifying power will be less. It will be just D by F. And when your eyes are strained, that's when the magnifying power will be more, and it will be 1 plus D by F. Understood, my warriors? Very, very important derivation. Yes, very, very important derivation. Okay, you all should know this. Let's move to some problems. And I have put up all these things as final result as well for your reference in printed form. Let's do this. First question coming up on your screen, and here it is. A convex lens of focal length 3 centimeters is used as a simple microscope by a person having least distance of distinct vision as 30. Some different person is not having normal least distance, something else, 30. What is the maximum value of the magnifying power? Very interesting. Is the magnification will be maximum? Yes, Ankit, you asked the correct question, and in fact that is what has been asked. When do you think the magnification is maximum? Is it at normal, or is it at distinct, or something else? Obviously it is when you have placed the object in such a manner that the image is as close as possible. That means at least distance of distinct vision. Yes, least distance of distinct vision. So basically this will happen at the strained position, basically at least distance of distinct vision. Fair enough. And what is the magnifying power then? Magnifying power then is 1 plus D by F. Do I know the values? I think so. Let's see. What is the maximum value of the power? And D value is given to be 30. The focal length of the lens is given to be 3 centimeters. So this will be 1 plus 10, which is nothing but 11. Should I put diopters? Should I put diopters? No, don't put diopters. This is not per meter. Many students fail to realize this. I'll go back a little bit. By the way, the answer is 11 only. And if I go back a little bit, you will realize M is a ratio. It is dimensionless. Very, very crucial. Many students don't know this. So this is basically dimensionless. Dimensionless. And it is not the same as the power of a lens or mirror which has the unit of diopters, which is also meter inverse. This is not the same. Okay, it is not the same. Very, very important. Okay, it should be there in your notes, and it will be also available for you guys to download in the PDF form later on. Next question. For waves IIT aspiration, it's already there. I have conducted it last year. You can find it It's there in the flash playlist. Go search in the flash playlist. It's there. Yeah, you will find it. Plus you will find my Zero to Hero series. You will find it many places. It's there. Wave optics is done in Pathfinder. It's already there. Only for nurture, it has to be conducted. So it will be conducted obviously after a few more days. Only after, thermo is over. It was over just last week. So that means it will be conducted next week. A simple magnifying lens is used in such a way that an image is formed at 25 centimeters from the eye. In order to have 10 times magnification, the focal length of the lens should be nearly how much? How much should it be? Think about it. Alright, the simple magnifying glass which is used, what is given in the question? The image is formed at 25 centimeters away from the eye. If this information is given, that means it is basically strained. It is strained and the image is formed at the least distance of distinct vision. That means the magnifying power formula will be 1 plus d by f. So 10 times magnification, that means m is 10, is equal to 1 plus the focal length, I don't know, d is 25. So this is 25, this is f. So therefore 25 by f is nothing but 10 minus 1, which is nothing but 9. So f will be 25 by 9, but this is in centimeters. This is like 25 by 10. 9 and 10 are very close because I can see the options over here. So 25 by 10 is roughly, okay, this is approximately, I'm just putting approximately over here. This is nothing but 2.5 centimeters. So many students will go ahead and if there was 2.5 they will mark it, but be careful, if the options are in centimeters or millimeters you should check it. There is no such option in centimeters, so convert it into millimeters. So 25 millimeters, hence 25 millimeters, which is option C, will be correct. Is that understood? Hi AK Gaming TPT. Perfecto. Let's move on to the next one. Beautiful question. So after this I'm pretty sure you're going to gain a lot of confidence for solving these questions. Okay, Gautam, just go to playlist, go to Pathfinder. In that, go to physics Pathfinder. Click on it, just scroll down, you will get it. Or in the yesterday's class, towards the end, I have explained where the Pathfinder series is and how to find any kind of lecture. It's there. Just go ahead and make that effort. At least that much effort you should be able to put. Okay, next. Let's talk about microscope. One device already done, eye defects already done, only microscope and telescope remaining. You guys are doing very well. Just in the next 1 hour or so, guaranteed 4 marks in your pocket from JEE Mains or BEDSAT or whichever competitive exam you are giving. Aditya, I just keep on removing it or keep on, having my beard depending on my mood. So it's random. It's just gone. I shaved it, obviously. Okay, there we go. Microscope. So in a microscope, the idea is to magnify a small object by using multiple lenses. And in this case, in JEE, we have 2 lenses which will help and assist magnify the small microorganism or whatever object is there very close to the lens. So let's have a look at what the ray diagram for a microscope or a compound microscope basically looks like. Okay, this is how a microscope actually looks like in case you have not seen it yet. All right, so let's move to the ray diagram. Yes, this is Jyotsna, this is JEE Mains level, because in JEE Advanced you don't have optical instruments. It's not there. Okay, it's only there for JEE Mains, nothing else. Now, what happens is for a compound microscope is that you will see that the object is placed very close to one of the lenses. These 2 lenses, they have particular names. This lens over here is called as the objective lens. It has the focal length FO. FO is generally very small, and then you have this called as the eyepiece. That means it will have some focal length FE. So this is where basically your eye is. This is where your eye is. So the eye is very close to the eyepiece. Every distance is measured from this lens. Then, okay, fair enough. This is my object right over here. This object is placed beyond the focal point. It's not placed before, it's placed beyond the focal point. So this is probably where the focal length of the objective will be. So because of which the image which is there, it will be real in nature. Only when the object is here, that's when the image is also virtual and on the same side. So you will get a real image probably somewhere here maybe, okay, and enlarged. Okay, you will get it enlarged. So this is the first magnification which is happening. So this is your intermediate image, I1. This is not your final image. This is your intermediate image. It's slightly magnified but inverted and real. But you cannot see a real image. So what you do is make sure that that image is between the focal point of the eyepiece. That means this image will now act like the object for the second lens. It will act like the object for the second lens, and you will see that when the rays go and they probably go like this somewhere. If you extend it backwards, you will probably see the image getting formed somewhere over here. Okay, I'm just showing a random position. Don't take it to scale. I have not drawn everything accurately, but this is the rough way of visualizing it. So this is where your final image is formed. This is how it looks like. Yep, very good. Semiconductors will be done, Shri Harshit, later on, not now. Okay, it's going to take some time. All right, after modern physics. Let me also start marking all the distances now. It's a good time to mark the distances. This distance over here will be called as the image distance for the eyepiece. Then this distance over here will be called as the object distance for the eyepiece. Okay, then you have this distance over here, which is the object distance for the objective, and finally this distance, which is the image distance for the objective. Okay, now let's see how many of you can write this out very easily. What do you think is the length of the microscope? Meaning the distance between the objective lens and the eyepiece. So what do you think is the length of that microscope? That L, think carefully in terms of these variables. What do you think it is? Observe carefully the distance between this lens and this lens. See if you can fit in some of these variables. I think it is this distance plus this distance, this plus this. So shouldn't it be nothing but VO plus UE. Just check this out, VO plus UE. Let's see how many of you have written it correctly. Very good, Jyotsna. Very good, Sri Harshit. Excellent. Sir, is this compound microscope or simple? Simple microscope was a magnifying glass, Akib. This is compound microscope. Okay, this is a compound microscope. Fair enough. Very good, very good. Now, the next thing you should understand is we would be interested in the magnifying power of this kind of a device. So when I'm talking about the magnifying power, what do I need? The angle subtended by the final image at the eye. So for finding that, I think I can do one small logical thing. The rays which will be going through the center of curvature, center, will go unaffected, and if I extend it backwards, probably it is going to meet over here. This is how it is going to look like, correct? So the angle subtended by the final image at the eye, shouldn't that angle be this angle, my warriors? Shouldn't it be theta? I hope this is clear. This is the angle theta. Everybody understood this? Next thing. Now, I want you to realize that when you talk about theta, okay, the final angle subtended by the image, this angle has come after it has magnified this intermediate image. After it has magnified this intermediate image. So let's keep that in mind also. Remember, the intermediate image is already magnified because of this lens. It's already magnified because of this lens. So this object got magnified and then it has got magnified here. So there are two magnifications which have happened over here. Is that understood, my warriors? Perfecto. Now let's take the two cases. I'll go on the next slide. I will come back to this. But the two cases are as follows. Observe this. When you are at normal vision, that means the final image is formed at infinity. If the final image is formed at infinity, that means VE is basically infinity. VE is basically infinity. If VE is infinity, that means if the final image is at infinity, think where should the object be placed? Where should the object be placed? Think about it. The object should be placed at the focal point. The object should be placed at the focal point of the eyepiece. So UE is basically nothing but F. See if everybody has got it. Is this particular chapter, this is the last session? Yes, Neville, this is the last session of this chapter, but there will be more sessions later on as problem solving sessions or mentees or advanced problem solving sessions and all of that. Fair enough? Good. Now, coming back over here, the magnifying power, very, very important. The magnifying power of a microscope will be, there will be product of two things. Why will there be product of two things? Because this lens is already magnifying this object and then it is getting magnified here. So think carefully that this eyepiece is actually acting like a simple microscope. How many of you realized it? Because this intermediate image, which is the object, is placed between the focal and the lens, between the focal point and the lens. So it is actually acting like a simple microscope. So it is the magnifying power of the simple microscope into the magnification due to this lens. So it is basically the magnification due to the objective multiplied by the magnifying power of the eyepiece, which is nothing but a simple microscope. How many of you got this? Very good. Perfecto. So compound microscope is nothing but a simple microscope in addition to another convex lens. That's it. So that you increase the magnification. You can see multiplication happening over here. Very, very important formula. So hence, think now what would be the magnifying power in this case. The magnifying power will be magnifying power of this objective. What is the magnifying, or what is the magnification of the objective? Think, what is the magnification due to a simple convex lens? It is V by U. So it will be nothing but V by U, but this is for the objective, so I'll put O over here. So remember, this is the objective lens. This is the objective lens, and this was your eyepiece. This was your eyepiece. Perfect? Understood? Into, I have to multiply. Remember, I just showed it to you over here. Into magnifying power of the eyepiece. What is the magnifying power of the eyepiece? The magnifying power of the eyepiece, that means simple microscope, normal vision. That means it should be D by F, as simple as that. It is D by F. Is that clear? Yes, it's no. Yeah, it's D by F. Very good. Proud of you, my warriors. Excellent. Now, similarly, if I talk about the least distance of distinct vision, okay, basically for the strained eye, what will be the magnifying power? It will be again similar. The first term will be the same. The first term is the same, magnification due to the objective, which is nothing but V0 by U0 multiplied by. The next term is magnification power of the eyepiece, but this is LDDV, least distance of distinct vision for a simple microscope. What is it? It is 1 plus D by F, but this is the focal length of the eyepiece. That's it. That's the final formula. Got it? Got it? Very good. Rohan, I'll conduct a session very soon for the expectation of JEE Advanced and what to plan. Hold on for that. But it will not be before May. It will be after June only. Okay. Now there is one small approximation which needs to be done. Very important. Understand the derivation part of it. Okay. Understand the derivation part of it. So let's go back a little bit and let's probably do that derivation maybe over here in this little space that I have. Now, it so happens that approximation comes because the focal length of this objective is very, very small. This focal length is very small. So because of that approximation comes. Observe this approximation carefully. So I'm probably going to just do it over here. For the objective, 1 by VO minus 1 by UO is equal to 1 by F. Everybody gets this? Pakka? Very good. So now if I do this 1 by UO, this will be nothing but 1 by VO. Take this 1 by F here, 1 by UO over there. So 1 by VO minus 1 by F. So this will be F minus VO divided by F times of VO. That is nothing but 1 by UO. I hope this is clear, my warriors. Okay. Now remember, in the magnification due to objective, this part, okay, this is nothing but VO by UO. If you remember it carefully, it was image by object distance. So let's try to find VO by UO and let's see what do we get. Okay, so take VO over there. So VO by UO will be F minus VO by F, which is nothing but 1 minus V0 by F. But this F was always for the objective. So I'll put F0 everywhere. F0 or FO everywhere. FO stands for the objective's focal length. Now what did I tell you? FO is very, very small. I mentioned this. FO is very, very small. That means V by F will be very, very large. V by F will be very, very large. So don't you see that this number which I'm talking about here is very large, and the reason why it is large is since FO is very, very small. FO is very, very small. That means 1 minus 1000, 1 minus 200, 1 minus 200, 1 minus 1000 is almost minus 200 or minus 1000. Got it? That means this will be roughly minus V0 by F0. See if you guys understand this. This will be roughly V0 by F0. Everybody understanding this? Perfecto. Got it, my warriors, till this point? Very good. Now the last approximation over here. Okay, the last approximation over here is this. This VO, the image distance for this objective, is roughly the length of the lens, usually, because this image which is formed intermediate is generally formed very close to the lens so that the image gets magnified. I'll repeat, this image generally is placed in such a manner that this image forms very close to the lens so that the image gets magnified. And not just that, you will see because the image is very close to this eyepiece, this distance is roughly the distance between the two lenses. So usually L and V0 are same. Usually L and V0 are the same. Everybody getting this idea? So because of which this value usually usually. This L is roughly equal to V naught. So this value of V naught by U naught will become minus L by F naught. So you can use this ratio for this value, V naught by U naught is minus L by F naught most of the times. You can use that. Yep, I hope this is clear. So many of the books you will also see after approximation, the magnifying power formula will be minus L by F naught into D by F. That's what you will see. But this F is the focal length of the eyepiece. Let me remind you, this is the focal length of the eyepiece. Same thing over here. Instead of V naught by U naught, after approximation, what can you write? You can write the magnifying power is minus L by F naught into 1 plus D by Fe. That's how it is. I hope you guys have understood this topic now. This is all that is there in microscope's ray diagram. Main thing that you should know is, I'll tell you what and all you should know. Length. But you don't have to remember the formula. Sir, was it VE by U plus UE? Was it UO plus VE? Nah, think logically. It will be image distance from the objective plus from here you measure it. So object distance for the eyepiece. That's it. Number one. Number two, what you should remember? The total magnifying power is magnification due to objective into, this is simple microscope. So simple microscope's magnifying power. Now, if it is least distance of distinct vision, if it is least distance, then it will be D by F. Sorry, my bad. It will be 1 plus D by F. And if it is normal vision, then it will be just D by F. Rest, the first term is simple. It is V by U. That is your normal magnification for any lens, V by U. And only when you use the approximation, only when you do this approximation which I have done over here, like the objective is very small and the length is almost the same as VO, then you will get this ratio as minus L by F naught. That's it. That's all you need to know. Okay. Got it? Very good. And the last thing over here, okay, I've put up all the formulas and the ray diagrams in printed form also, so that you have it in a neat way. The magnifying power for distinct vision as well as for normal vision. And the only thing remaining over here is the resolution of images. So resolution of images meaning, can you see the images distinctly? Because when the rays travel through the aperture, through the hole of the lens, they get diffracted. And once the rays are diffracted, you will see for a point object, you don't get a point image, you get an airy disc. How many of you remember this from light waves? Raise your hand. How many of you remember this? Thank you, Deepak, for all the fire and hearts. Yeah, for a point object, you do not get a point image because of diffraction. The rays will spread, it will bend, and because of which you will get an airy disc. Airy disc means a blurred image. So a point object will give you an airy image, airy disc image, and that's the reason why if you have two objects, 2 point objects, you will get 2 airy discs, 2 discs. If you get 2 discs, then the images can be blurred, they can appear to be merged. So you want to see those discs separately, they should not touch each other. That's the meaning of it. This is completely resolved. This is definitely not resolved. Both the discs are onto each other. You cannot distinguish between the 2 particles. It feels like only 1 particle is there. Here, somewhat you can make out, but it's still not clear. Here you can now understand, yes, there are 2 objects because you can see the images distinctly. So these are resolved images, and the limit of resolution, the minimum distance between these 2 should be there. Otherwise, you will not be able to see the objects clearly through the microscope. So that D is given by lambda by 2 mu sine theta. D is given by lambda by 2 mu sine theta. What is this D? Let me mark it. This is your limit of resolution. Limit of resolution. That means the minimum distance between those 2 images. Next, what is mu sine theta? This mu sine theta is also called as the numerical aperture. Okay, numerical aperture. Usually what happens, you keep the microorganism or whatever object you want to see under the microscope in a slide. There is some liquid layer. So there is some liquid between the object and the objective. So that material will have some refractive index. That's the mu of that medium. Theta is the angle, cone angle at which the light rays are entering into the microscope. Usually it is given. If it is not given, you will be given the product of mu and sine theta. Lambda is the wavelength of the light which is entering inside. Now, if this d is small, that means this distance is very small. That means the two things can be as close as possible to each other, which is very good. So the diffraction is less and the power of resolution is more. Resolving power is more. As simple as that. So resolving power is inversely related to the limit, the minimum distance at which those two objects should be. Those two microorganisms or 2 points should be. So before which you will not be able to see them clearly. Only after the limit of resolution you can see them clearly. So that's why it is inverse of that. More the distance, less the power. Less the distance, better is the power. That's how it works. Okay, I hope this is clear. Very good, very good. NCERT class I have already mentioned in my previous classes when I'm going to start with, so you can have a look at the previous lectures and you will definitely get the updates whenever I'm going to start with. So you should join the Telegram channel, you will definitely get it over there. Okay, don't keep disturbing the class in between. Okay, plus this is a 12th standard class. Next, moving on to the next one. Here is a question coming up on your screen. The separation between two microscope particles is measured as PA and PB. The separation between two microscopic particles is PA and PB by two different lights of wavelength 2000 Armstrong and 3000 Armstrong respectively. Then which is more, which is less? Come on, think about it. Okay, let's see. Actually, this should have been not just any separation, this should have been the minimum separation. Let me just add the word the minimum. The minimum separation between two microscopic particles under two microscopes is basically PA and BB. Basically what this means, the minimum separation means this is nothing but your limit of resolution. And do you guys remember what is the limit of resolution dependent on? Come on, put it up in the chat box. What is the limit of resolution dependent on? The limit of resolution is directly proportional to, go back, you will see it clearly. It is directly proportional to lambda. It's not inversely. Power is inversely proportional to lambda. D is directly proportional to lambda. So this is basically directly proportional to lambda. That means PA by PB will be lambda A by lambda B, which is 2000 Armstrong divided by 3000 Armstrong, which is 2 by 3. Naturally, PA is less than PB. 2 by 3, it's less than 1. So PA is less than PB. So option B is definitely correct. Yep, very good, excellent. Moving on to the next question coming up on your screen now. Okay, here it is. Interesting question on compound microscope. Let's see what it means. There is a compound microscope which uses an objective lens of focal length 4, eyepiece 10 focal length, object is at 6, object from the objective lens, find the power, find the length of the microscope. For your reference, I have just drawn the rough diagram of the, or just kept it for you guys so that you can visualize it. Okay, let's see what and all we know and let's start solving the question. FO, objective focal length, is 4 centimeters. FE is nothing but 10 centimeters. The object is placed at 6 centimeters from the objective lens. That means UO is minus 6 centimeters. That means the object is 6 centimeters behind the objective lens. So it is minus 6 by sign convention. Next, find the magnifying power. Now you will be wondering, sir, it is not even mentioned whether it is at least distance or whether it is in normal vision. Okay, you only logically think and tell me, when you are observing things under a microscope, will your eyes usually be strained or relaxed? Put it up in the chat box, because without that you cannot solve the question. Let me tell you that. What do you think it should be? Will the eyes be relaxed, or do you think it will be under least distance of distinct vision? Think carefully and let me know. Think carefully, guys. Yep, obviously it will be strained. Neville says strained. Perfect, perfect, it will be strained. So usually when it is not mentioned, understand that it is under the strained condition. That means, I also know one more thing, the final image distance from the eyepiece is minus 25 centimeters. So since it is not mentioned, you have to always assume this for a microscope. Okay, so let's try to find out all the things needed, because without VO, without UO, I don't think I can find out length, anything else. Use lens formula, nothing else, you will get it. Trust me on this. Let's do this for the objective first. For the objective, look at this. For the objective, I can say 1 by VO minus 1 by UO is equal to 1 by FO. Therefore, 1 by VO I don't know, minus 1 by UO is minus 6, is equal to 1 by FO is basically 4. So 1 by VO minus plus, when it goes that side, it will again become minus. So it will become 1 by 4 minus 1 by 6, which is 6 minus 4, right, by 24, which is 2 by 24, which is 1 by 12. So therefore VO is nothing but 12 centimeters. Just see if you guys have got this as 12 centimeters, my warriors. Very good. Next, let's try to find out the magnification of this. Let's try to find the magnification of this. So what's the magnification formula? The magnification formula was VO by UO into, since it is least distance of distinct vision, remember it is 1 plus D by FE. Eyepiece acts like a simple microscope. The objective acts like a normal lens. Magnifying power into, magnification into the power of the lens. That's it, power of the simple microscope. That's all. So what is VO? I think I know it. Let's start substituting it. VO is 12. So put 12 divided by UO is 6. I'm interested only in the magnitude. Ignore the signs. So I'll just put 6. I'm not interested in the negative values. Okay. Into 1 plus. If you want, you put it. See, that negative sign will just imply that it is inverted. And we know that under a microscope, the images are always inverted in nature. That's okay. 1 plus D by F. D is nothing but 25. Focal length is nothing but 10. So 12 by minus 6 is minus 2. 25 by 10, that's 2.5. 2.5 plus 1, that's 3.5. Okay, 3.5 into 2 is 7. So magnifying power is basically 7 times. Very good. Yes, minus implies inverted. So this implies inverted, nothing else. Otherwise it is 7 only. Next, length of the microscope. Oh, for length, I need this distance plus this distance. Let's see what and all I know. I'll mark it over here. Observe this carefully. I need this distance and I also need this distance. This is image distance for the objective, VO. I have found that out. This is object distance for the eyepiece, UE. That is something I don't know. So find that out. How do I find that out? Observe this again. Okay, look at this. To find UE, solve it using the lens formula for the eyepiece. So for the eyepiece, again use the lens formula and see what do you get. 1 by VE minus 1 by UE is equal to 1 by FE. Fair enough. So therefore, 1 by VE, VE is minus 25 minus 1 by UE is equal to 1 by focal length. Is the focal length known? Yes, it is 10 centimeters. Fair enough. So therefore, 1 by UE, check this out. What is 1 by UE? Take it on the other side, bring 1 by 10 on this side. So it will become minus 1 by 25 plus 1 by 10. So let's take LCM and see what do we get. So therefore, 1 by UE will be equal to, minus is common, LCM is 50, so 25 goes 2 times, so 2, 10 goes 5 times, so 5, divided by 50, which is the LCM, so it will be minus 7 by 50, so therefore UE will be minus 50 by 7. Minus signifies the direction, it is on this side. It is just 50 by 7, which you can also write it as, magnitude wise, you can fabricate the minus sign. 7 sevens are 49, 1 and 4 centimeters. Perfect. Now, what you need to do is find the length of the microscope. So what will be the length of the microscope? The length of the microscope will be this plus this. So VO plus UE. So what is VO? VO is 12. I just got it here. It is 12. UE is 7.14. So what will be the final answer? It will be 19.14 centimeters. So that's the length. After solving this question, you will never face any difficulty. Correct, Kalpana? It is 19.14 and minus 7. Yep, that's the answer. How many of you loved this question? Put up a thumbs up in the chat box. Let me just drink some water now. All right. Let's do another question. Now, did you realize that it is nothing but lens formula? If you thought that, oh, lens problems, magnification problems, oh my God, microscope problems are very complicated. No, it's at the end of the day, just based on this ray diagram. If you understand the concept, it is very easy. It's just lens formula being applied. Next, this was asked as a PYQ, previous year question. Let's solve this question. In a compound microscope, the focal length of the objective lens is 1.2, objective. Focal length of the eyepiece is 3. The object is kept at 1.25 in front of the objective. Final image is formed at infinity. Find the magnifying power of the compound microscope. Let's solve this. This was a PYQ. Now, if you look at the question carefully, it is clearly mentioned that the final image is formed at infinity. If the final image is formed at infinity, that means the first thing you should understand that the eye is basically relaxed. That means if I want to find the final magnifying power, which is M, when I use the formula VO by UO, I should not use 1 plus D by F. I should just use D by F. This F is obviously focal length of the eyepiece. Got it? Now let's see what and all I know. D standard 25. Eyepiece focal length, I think it is mentioned over here. VO and UO are not given. That is the problem. VO and UO are not given. But here, probably it is given. When the object is kept at 1.25 centimeters in front of the objective. That means, what do I know? I know the object distance. Look at this. Object distance from the objective. So UO is minus 1.25 centimeters. The only thing I do not know is VO. If I find VO, my job is done. That's it. My job is done. So what do I do? Use lens formula. Do I have a lens over here? Oh yes, I have a lens. Probably I should have done it here. But anyways, use the lens formula and see what do you get. So use the lens formula. Use the lens formula for objective. And see what do you get. Well, it is 1 by VO minus 1 by UO is equal to 1 by F for objective. 1 by VO, I don't know. 1 by UO is nothing but minus 1.25. 1 by FO, F focal length of the objective is 1.2. Fair enough. So this will be 1 by VO is equal to minus minus plus. Bring it on that side. It will become minus again. So 1.25 over here. You can take LCM obviously. So it will become 1.25 minus 1.2 upon 1.2 into 1.25. Which is going to become 1.25 minus 1.2 is 0.05 divided by 1.2 into 1.25, which is same as 5 divided by 1.2 into 125. I've shifted the two decimals, numerator and denominator. 5 goes with 125, 25 times. So 1.2 into 25. Okay, let me just put it over here. So therefore, VO will be 1.2 into 25. 25 into 12, 300. So 30. So basically it will be 30 centimeters. So that's what is VO. So I think I found out everything over here. It's just a matter of substitution. That's how simple this question was when it was asked in mains in 2014. So VO is nothing but 30. UO is nothing but 1.25. D is nothing but 25. Focal length of the eyepiece is 3. So put 3 over here. 3 goes with 30 10 times. Okay, so that's what it is. And 25 and 1.25. So you can do one thing, 10 into 25. You can write this as 125 and divided by 100. So 100 goes on the top. 25 goes with 125 5 times. That's it. So this will go with 2 times. So this will become nothing but 200. So that's the magnification power. Okay, so that's option A. Hi Vaishal, I'm very good. Got it? So, yep, that's the answer. There you go. 200. It's simple, guys. You just have to have some patience, nothing more. Okay, let's go to telescope, the last part of this chapter. Great. Yes, Akash, I will definitely do it in PYQ sessions. I just have to solve so many questions, right? So I cannot take up all the questions at once, but yes, I'll definitely take up 2021 questions also. And by the way, I've already solved 2021 questions in the previous year paper discussions. So remember, last year, as soon as the paper was out, we solved all the questions. Then and there itself, immediately, within 1 hour. So you can see it's there in the playlist. You can go through the playlist. You can find any paper, any shift. You will get it over there. Okay. Moving on to telescope. Now telescope is the simplest thing. Trust me on this. Telescope. Now many people get confused. Sir, what is the difference between a telescope and a microscope? See, I'll tell you what. In a microscope, number one, you see a tiny object which is close by. The object is very close and it is very small. For a telescope, the object is very huge, but it appears to be small because of the distance. So that's why the construction is very different. For a microscope, if you have noticed in the ray diagrams, where did we go? Yeah. In the ray diagrams over here, the object was very close to the objective. Very close. It's a small object, but it is very close. But in a in a telescope, obviously you are not close to moon, Jupiter, sun, whatever. So the object is very, very far away. That's the major difference. So the object is at infinity. Coming back to this over here. The object is at infinity. And when you see the Jupiter, the moon, etc., through the eyepiece, this is the eyepiece, the bigger one is the objective. Your eyes are usually strained, or is it relaxed? Answer in the chat box. Very good, Akash. Using telescope, can we see planets or only stars? You can see everything. You can also see your friend from your neighboring building using a telescope. Yes, you can do that. Binoculars is also telescope in a way. Binoculars has very less magnification. Telescope has very big magnification. Okay? Yeah, it should be relaxed. Definitely. Some I have seen people using binoculars from boys hostel to girls hostel also during my college days. Yeah, so many people do that. Okay, so you guys are not going to do that, I hope. And let's see how the ray diagram for a telescope looks like. Now, here it is. We have the objective again. Okay, I think there is some mistake over here. My bad. So I'll just rearrange it from the other side now. This is the objective now. Okay. Now you will be wondering, sir, why are you switching to this side? This is objective, this is eyepiece usually. Now, the bigger one is objective now. Reason, the aperture should be large, because if the aperture is small, then you will collect very little light, number one. Number two, the diffraction effects will make sure that the light will spread. So the Jupiter or moon which is very far, the star which is very far, the light rays will diffract and you will hardly get any image. So you have to get a very big aperture. Very good, Neville. Thoughts match. Proud of you. I'm so happy our thoughts match. I thought I am the only indecent one out here. Good. I have a very nice crowd, supporting crowd. And then here we have the eyepiece over here, which is small. Obviously, there is no point of having a big eyepiece. Many students ask, sir, why can't we have a big eyepiece? Your eye is this small. So that's it. You need a lens which is only this size. There's no point having it this big size. Correct. Very good. So this is an eyepiece. And the rays of light come from infinity because the object is very, very far. Object is very, very far. So the rays will come from infinity. And what you will see, okay, just hold on. Yeah, let me just remove this first. Let me mark the focal length. This is the objective. So probably this is the focal point of the objective. So the rays which come from infinity, they will roughly make an image at the focal length. That's obvious, right? If the object is at infinity, the intermediate image is formed at the focal length. And this distance, I can also call it as V, VO. So this is VO, and you can see over here UO is basically infinity. This is VO. Now this image is amplified, magnified, thinking as if it is an object and this is a simple microscope. So the eyepiece is nothing but going to act like a simple microscope. And we all know what does a simple microscope do? What does a simple microscope do? It makes sure that the object, when you see through a simple microscope, the object is between the focal point and the lens, and you see a virtual image. So try to keep this image between the focal point of this lens and this point over here. So once you keep this image between the focal point and the center of the lens, this image will be enlarged and it will be virtual. That's all. So this acts like a simple microscope. So the later on stage, what you will see is these rays will go like that, and you will see that the virtual image is formed at infinity. Okay, so these rays will be entering your eye. I can draw more rays obviously, but I'm not shown that. So the final image which is there, okay, let me just mark it right from here. All right, there we go. Yeah, so the image is formed at infinity. So always the image distances are measured from this particular lens, which is the eyepiece. So VE will be like this, and this will be V, oh sorry, my bad. This will be nothing but, yep, it will be UO. Crazy, right? VUOE is like a tongue twister out there. Yeah. And if this image acts like the object for this lens and the image should form at infinity, that means this UO should be nothing but the focal length itself of the eyepiece. The focal length of the eyepiece. Understood? Because the image is formed at infinity. So the other focal point, FE is also here only. That's it. FE is also here only. Now, if I ask you what is the length of the telescope, this is the length of the telescope. Can you not see what the length should be? It should be this plus this, which is UO plus this distance, which is V. Oops, sorry guys, this was not UO, this was UE, my bad. This was UE because this is eyepiece. I'm always thinking from this perspective because objective was here and eyepiece was there. My bad. This is UE. All right. I'm so sorry. So this length should be nothing but UE plus this distance, which is VO. And UE is nothing but FE, and VO, that's nothing but the focal length, which is FO. So that's the length of the telescope. This is always under normal vision. Normal vision. So that's why the image is formed at infinity. Lastly, the magnifying power, you can derive it very easily using same techniques. It's very simple. I don't know how many of you know this, but it is simply put F by F. But is it FE by FO or is it FO by FE? That's the common confusion. Come on, let's see how many of you remember it. Is it FO by FE or is it FE by FO? Come on, my warriors, tell me. Is it FE by FO or FE by FO or FO by FE? Okay, I'll give you a hint how you can remember it. See, for microscopes, it was something into 1 plus D by F, where F was the focal length of the eyepiece, or it was something into D by FE, where you see it in the normal vision. Always FE is there in the denominator, if you notice. So remember, for telescope also it's the same thing. So it is always FO by FE. Understood? Okay? So it is always FO by FE. Keep this also in mind. Two important formulas: length and magnifying power. You do not have the least distance of distinct vision formula. Don't worry about it. Okay? But still, if you want it, I have kept it on the slide, but as such it is not there in the syllabus. Only normal adjustment is there, nothing else is there. Let's solve some questions, but before that, resolving power of a telescope. Just like you had resolving power of a microscope, the resolving power tells you the ability of a telescope to resolve the images distinctly, clearly, without there being any interference because of the diffraction patterns. When the light rays enter through a hole, they bend, they spread. You do not want the interference between the images of the two objects which are formed. So, the two images, if they are separate, it's resolved. If they overlap, then it is not resolved. So that minimum distance that should be maintained between the objects so that the images are clear, distinct on the eyepiece is the limit of resolution. And that formula is again mentioned over here. But remember, in this case for a telescope, it is not a distance, but it is the angular limit. So this is the angular limit of resolution. Angular limit of resolution. Why am I using the word limit? It's the least angle between the two objects to be seen like this. So if you want to see it clearly resolved, so that's the least angle between the two objects that should be maintained so that the images don't overlap in this manner. Lambda is obviously the wavelength of that particular light. What is D? It's the size of the basically the lens. Sometimes it is also called as the aperture. It is also called as the aperture. The diameter of that lens. It's also called as the aperture. That's it. So keep this in mind. Inverse of this angle is called as the power. Because if the angle is less, that means the objects can be very close and you can still see it clearly. So it has better resolving power. That's what it means. Okay, let's solve some questions based on this. Come on, my warriors. A telescope of some aperture diameter 5.5 meter, it is used to observe the moon from Earth. The distance between the moon and Earth is 4 into 10 to the power 5 kilometers. The minimum distance between the two positions on the moon surface where you can see it clearly, it can be resolved using the telescope is how much? Wavelength is also given. Let's see how many of you can do this. Very interesting question based on resolution. Come on, think, which formula are you going to use? Which formula are you going to use? So before that, let's see and visualize what we need to do. So imagine this is a telescope. Okay, this is your telescope right over here, and this is the surface of the moon. There are 2 points over here, let's say P1 and P2. You want to see these points clearly. That means That means there should be minimum del theta angle, which is the limit of resolution between these 2 points subtended at the telescope. That is what it is. Here is where your Pandu is observing through the telescope. Minimum that much angle should be there. Without that, he will not be able to see those 2 points on the surface of the moon. This is on Earth. This is on Earth. Now, the distance between the moon and the Earth is also given. That distance is somewhere over here. Let's say I call it as r. Now, the question is, what should be the distance between the 2 points P1 and P2? So to find that out, think what we should do. P1, P2, the distance P1, P2, can I not say it's almost like the length of an arc, where this is the center, this is the radius, it's like the length of the arc, r is the radius, this is the angle subtended. Shouldn't it be nothing but r into delta theta? Can you see that, my warriors? It is r into delta theta. Very easy now. What is delta theta? I've just given you the formula for delta theta. Delta theta, what is it? Just go back. 1 by delta theta, I had told you it is 1.22 lambda by d. So delta theta will be 1.22 lambda by d. So that's it. Just put it over here. It is 1.22 into lambda divided by d. Now start substituting the values. Lambda, what is lambda? It is 5500 Armstrong divided by d. What is d? It is 5.5. So bring it into proper powers. So 1.22 into 55 Armstrong, 10 to the power minus 10, 10 to the power 2, so 10 to the power minus 8 divided by 5.5. So I'll just put it as 55 into 10 to the power minus 1. So this will be nothing but 1.22 into 10 to the power minus 7. I hope this is clear. Now once I get the value of delta theta, just substitute it over there. So this will be nothing but r. R is nothing but the distance, which is 4 into 10 to the power 5 into delta theta, which is 1.22 into 10 to the power minus 7. 4 into 1.22, come on, how much is it? 4 into 1.22, how much is it? 4.88, yeah, 4.88 into 10 to the power minus 2, I believe. Just check this out if everything is fine. Yep. So this is fine, this is fine. All right, everything is clear over here. So I am getting 0.488, but oh, wait a minute. This is in kilometers. Yes, this is in kilometers. So I need to convert it into meters. So I need to multiply this entire thing by 10 to the power 3. So into 10 to the power 3, that means it will be 48.8 meters, which is very close to 50 meters, I believe. Very close to 50 meters. Yep, that's the answer. Just check this out. Oh, the answer given is wrong over here. Ignore that. The correct answer is 50 meters. Okay, just ignore. Yep, it is 50 meters. Perfecto. It is not C, it is not 500. Be careful, Kalpana. 4.88 into 10 to the power minus 2 into 10 to the power 3. It will be into 10. 4.88 into 10 will be 48.8, which is very close to 50. All right, moving on to the next question. Focal length of the objective of a telescope is 1. The magnifying power is 20. What is the length for the relaxed eye? Direct formula, trust me on this. Nothing great about it. The magnifying power of a telescope when it is relaxed, what did I just tell you? It is f0 by fe, right? I just mentioned this. So m is given to be 20. f0, focal length of the objective is 1. That means this is 100. fe, I do not know. I'll just put fe over here. So fe will be 100 by 20, which is 5 centimeters. Got it? Next, did I not tell you the length of a telescope is just f0 plus fe? I just gave you that just some time back over here. You can see it right over here. I've given it to you. It is f0 plus fe. That's it. So use that formula right over here and you will get the answer. So f0 plus fe. f0 is nothing but objective's focal length, which is 100. Eyepiece is nothing but 5. So this is nothing but 105 centimeters. As simple as that, which is option C. Correct. Very good. Very good. So that's how the answer is. Now I'm pretty sure after this you would have gained confidence on this topic. Please rewatch the session if you have joined in late. If you have missed the class for some reason, start from the beginning, because if you start somewhere in between you will lose. So make sure you start from the beginning. And here are your homework questions. This is your first homework question, second homework question, third homework question is over here, and the fourth homework question is right over here. Solve this today itself so that you will gain confidence. And yes, if you want these kind of amazing lectures, you want detailed problem solving sessions, you want doubts to be solved, and you also want part and full syllabus test, and you want your comparison with previous all India ranks, you want a gauge which will tell you where you stand, predicted rank, also you want summary, notes, everything, class recordings with PDF, notes, all of this is available in your JEE crash course, which is meant for all the 12th and the dropper students. Usual price is 20,000, discount you will get 10,000, but when you use my coupon code you get additional discount. Usual discount is 10%, but you will get more, 20% off. Instead of 9,000 you will get this for 8,000. If you don't believe me, just go to the channel video description box. So if you're watching my video right now, all you need to do is just go below over here and see the JEE crash course. Just click on this. Select your target exam. It's JEE 2022. You can choose this batch or even the previous batch. It will end before. So you can choose this or this. Anyways, you will get all the missed classes as well. And when you use my coupon code SHHPRO or SHHCC, you save 2,000 rupees and you get it for 8,000. You can see that right over here. You have multiple options to pay as well. And you can see what and all is available, the timetable, the FAQ, everything is mentioned right over here. It's a Republic Day offer, and that means it will be only available for a certain time. That means only till 31st. After 31st, that means Monday, you will see the offer will be invalid and it will come back to the original price. So Abhishek, I'll be starting waves next week, okay? Monday. Till then, bye-bye. Have a great time. Light waves I have already done. Okay, what am I going to do in 12th standard next week? I'm going to do modern physics. So complete modern physics, and after that semiconductors. That's it. So that's my plan for next 2-3 weeks till 14th of February, and after that we're going to do more of revision and problem solving, PYQs, mock tests and all of that. All right, that's it for today. Thank you so much for tuning in. Thank you for smashing the like and also hitting the subscribe button. That's it from my side. This was Captain Shreyas signing off. Hasta la vista.